Welcome to the Cost Estimator tools for well completion and surface plants, alongside the Environmental Impact Estimator, developed by TVS. These tools are designed to support cost and environmental analysis for geothermal projects, helping engineers and decision makers plan efficiently and confidently. The well completion cost estimator consists of two main components: laser cladding cost estimation and casing and cementing cost calculation. The laser cladding cost estimation module evaluates the overall cost of laser cladding operations. It includes fixed costs, variable costs, productivity analysis, and total cost calculation. The casing and cementing cost calculation module estimates costs based on detailed well and casing parameters. Users can define the well depth, for example, 5,000 meters. The tool supports multiple casing and liner types, including surface casing, upper production casing, intermediate liner or anchor casing, and production injection intervals. For each casing or liner, users can input detailed technical specifications, providing a transparent and detailed cost breakdown. After clicking the Calculate button, the tool automatically computes casing and liner properties, including material thickness, cement volume, mass, and associated costs. It then evaluates casing and cementing costs per interval length and derives functional cost metrics for each section. Finally, the system summarizes laser cladding, casing, cementing, and overall well completion cost per unit length of drilling. The surface plant cost estimator requires detailed input across multiple sections, including scenario definition, economic parameters, permitting, exploration, drilling, reservoir characteristics, geofluid gathering, power plant configuration, and operation and maintenance. Users select the plant type for LCOE analysis, after which default input parameters are automatically populated from the Compass database to streamline data entry. These defaults cover approximately 100 input parameters. Using these inputs, the system calculates the levelized cost of electricity. After calculating the levelized cost of electricity, the tool enables sensitivity analysis of net present value, payback period, internal rate of return, and return on investment to support informed decision-making. The Environmental Performance module for well completion is based on a cradle-to-gate life cycle assessment (LCA) model. When users navigate to this module, the first step is to estimate resource consumption for different types of casing and liner materials. Upon selecting a casing or liner type, the corresponding material properties are automatically retrieved from the Compass DBMS, with the option for users to modify these properties by entering custom values. After selecting the cementing material type, outer diameter of the casings, and hole diameter for each interval, users initiate the analysis to calculate resource consumption for casing and cementing materials. All material and energy flows are sent to the SimmerPro API, where background processes are modeled using the EcoInvent database, and environmental impacts are calculated using a life cycle impact assessment methodology, expressed per functional unit of 1 meter of drilling activity. The Environmental Impact Estimator for the surface plant is based on a cradle-to-grave life cycle assessment (LCA) methodology. It evaluates environmental performance using a functional unit of 1 kilowatt-hour of electricity production. Users can estimate resource consumption across the construction, operation, and maintenance, and end-of-life phases of a geothermal power plant by combining basic plant data with reference material and process flows populated in the DBMS. The estimator is linked to the SignPro LCA software via an API, which applies a life cycle impact assessment methodology to quantify environmental metrics. This tool was developed by TVS under the COMPASS project, which has received funding from the European Union's Horizon Europe Research and Innovation Programme. Credit for the development of this tool goes to the TVS Research and Development team, along with all associated partners of the COMPASS project,